Eugéne Ionesco. He's like a half French, half Romanian writer, poet, director. And he focuses mainly on the idea of absurd theatre. So what you'll see tonight is a bit strange, a bit weird, but it's all in the name of art. The piece is a one-act play, so I've had to chop it down a lot. And basically the characters that you'll see is a mad professor and a naive student. It's set in World War II, so the girl here is very privileged to have the education, have the tutoring, and the teacher has this recurring addiction to mass murder, shall we put it. He's in the previous bit of the scene, people's been sat down, people's been met by the teacher, and he comes in a bit late, washing the blood off his hands. And at the end of the piece, which you won't be seeing tonight, unfortunately, there is the death of the student. And then a few moments later, once he removes the body, the maid comes to the door and says, "Hello, student, come and sit down." So it's a recurring thing, recurring piece with different students. So hope you enjoy it.
Excellent. That's excellent. And so, if you don't mind, we could begin.
Oh yes, sir. I'm quite ready for you, sir.
Ready for me, or is it I who am ready for you? That is, of course, I mean, I'm at your service.
Oh really, sir?
Well, I will begin by giving you a brief examination on the knowledge you've acquired so far, and see which route you should take into the future. What is your perception of plurality?
A little vague and confused.
Fine. There is where we shall start. Now, if you don't mind doing a bit of arithmetic.
But of course, sir, willingly. I can ask for anything better.
It is a fairly new science, a modern science. Well, strictly speaking, it's a bit more of a method than a science. It's also a bit of a therapy. I'm not listening to anything you say. I don't care what you think. I can look after myself. I am old enough. Well, I'm not listening to your warnings. So sorry about the brief interruption. Perhaps we should get back to our arithmetical sheep.
I follow you, sir.
But still sitting down, I see. Good. Then we shall arithmetize a little.
I'll be pleased to, sir.
Then perhaps you wouldn't mind telling me what does 1 and 1 make?
1 and 1 make 2.
You are very good indeed. You will have no trouble passing your doctorate examinations.
I'm very pleased to hear it, sir, especially from you.
Let us proceed a little further. What do 2 and 1 make?
3.
3 and 1.
4.
4 and 1.
5.
5 and 1.
6.
6 and 1.
7.
7 and 1.
8.
7 and 1.
8 again.
7 and 1.
Still 8.
7 and 1.
8 again, and sometimes 9.
Oh! Yeah. You are truly magnificent, Mademoiselle. There is no point in continuing. Perhaps we should try something a little different. How about subtraction? tell me what is left when you take 3 from 4?
3 from 4. 3 from 4.
That is to say 3 minus 4.
That makes 7.
No. Mademoiselle, I am sorry to have to contradict you, but it is not 7. You're getting muddled up. It is not a matter of addition, but subtraction. You see, 3 plus 4, that makes 7, but 3 minus 4. What does that make? 3 minus 4.
4.
No, mademoiselle, that is not the answer!
3 then?
It's not right either, mademoiselle. I really do beg your pardon. It doesn't make 3. I'm terribly sorry.
4 minus 3. I suppose it wouldn't make 10.
Oh, dear me, no. Mademoiselle, you must really pay attention. You have to reason it out. Shall we try to solve it together? Would you be so good as to count?
Yes, sir. 1, 2, 3.
Stop there. You can obviously count that. Good. What can you count up to?
I can count up to infinity.
That is impossible!
16 then.
Let's see. Quite far enough. We must all understand our limitations. Go on counting then.
1, 2, after 2, 3, 4.
Stop. Which number is the greater? 3 or 4?
3 or 4. Which is the greater? In what way greater?
Some numbers are smaller than other numbers. In greater numbers, there are more units than there are in the smaller ones. If all the units are the very same, there'll be more units in the small numbers than there are in the big ones. That is, if they do not all have the same units.
In that case, small numbers can be bigger than big numbers.
Yes, well, we won't go into that. If you want, I just want you to realize that there are more things to life than numbers. Let us just suppose, to make it easier, that the numbers we're dealing with are all the same kind. Then the greatest number will be all of those that have the most units, assuming that all the units are the same kind.
The one that has the most will be the greatest. Oh, now I understand, sir. You're comparing quality with quantity.
It's a little, too theoretical, mademoiselle, too theoretical. You don't need to worry about that. Let us take an example and think it out in a particular case. Our general conclusions can come later. We have the number 4 and the number 3, each one having a number of identical units with numbers which will be greater. The smaller number or the greater number.
I'm sorry, sir, but what do you mean by the greater number? Is that the one that is less than the other one?
That's it, mademoiselle. You've understood me perfectly.
Well, then it must be 4.
What is 4, greater or smaller than 3?
Smaller. No, greater.
Excellent answer. How many units are missing between 3 and 4? Or between 4 and 3, if you like.
Well, there aren't any units, sir, between 3 and 4. 4 comes immediately after 3. There's nothing at all between 3 and 4.
I can't have made myself understood. It is obviously my fault.
Oh, no, sir. The fault's entirely mine.
Listen. Here are 3 flowers. And here is 4. 4. 4 flowers. Watch carefully. 4 flowers. I take 1 away. How many left?
5. If 3 and 1 make 4, 4 and 1 make 5.
You. That is not right. Not right at all. We have a constant pre-dedication for adding up. Let us get back to flowers. There are 4. And I take 1 away. That leaves me with...
I don't know, sir.
Come now, think a little. It's not easy, I admit. You are clever enough to work it out. Come on, put in some intellectual effort. Well,
I don't seem to know, sir. I really don't.
all right. We'll have some simpler examples. You have 2 noses. What if I plucked one off? How many would you have then?
None.
What do you mean, none?
Well, it's just because you haven't plucked one off, I've still got one now. If you plucked off, it wouldn't be there anymore.
You don't quite understand my example. Suppose you only had 1 ear.
Yes, and then?
And then I stick another one on. How many would you have then?
2.
Good. And then I stick yet another ear. How many would you have?
3.
Okay. I take 1 of them away. How many do you have?
2.
Good. I take another one away. How many do you have left?
2.
No. You have 2 ears. I take 1. I nibble one. How many do you have left?
2.
I nibble one of them. How many do you have left?
2. 2.
1!
2.
1! 1! 1! No, that's not right at all. The example is not good. Let us proceed in a different way. Let us, for the purpose of subtraction, stick to the numbers 1 through 5. Little patience, mademoiselle, you see. You're going to understand now. Watch. Watch carefully. Can you see? All right.
Yes, sir.
These are sticks, mademoiselle. Oh, 1 stick, 2 stick, 3 sticks, 4 sticks, 5 sticks. When you count the sticks, each stick is a unit. Mademoiselle, repeat what I've just said.
A unit, mademoiselle. Repeat what I just said.
The figures or numbers, 1, 2, 3, 4, 5. The elements of numeration, mademoiselle.
Yes, sir. Elements. Figures, they're sticks. Units and numbers.
Oh. Now then, you can count if you like, making use of these elements. Add up and subtract.
The sticks are figures and numbers units. You can subtract 2 units from 3 units, but can you subtract 2 2s from 3 3s, and 2 figures from 4 numbers, and 3 numbers from 1 unit?
No, mademoiselle, you cannot.
But why not, sir?
Just because, mademoiselle.
Because what, sir? Since they're all the same.
That's just the way things are, mademoiselle. It can't be explained. You understand it by sort of mathematical sense deep, deep, deep inside you. You either got it or you haven't.
There's nothing that can help me then.
Listen, mademoiselle, if you don't succeed in fully understanding these archetypal arithmetic principles, you'll never succeed in carrying on out with your work as a polytechnician. And what's more, no one will want to put you on a course of a polytechnic school or even an establishment for infants. For example, how much 3,755,998,251 multiplied by 5,162,335,508.
That makes 19,390 quadrillion, 2,844,290,164,5,408.
No, I don't think it's so. That must make 19 quadrillion, 390 quadrillion, 2,844,290,165,509.
No, 508.
By Jove, yours is the correct product. But how did you arrive at that if you don't understand the principles of calculation?
Oh, it's quite easy, really. As I can't depend on reasoning it out, I learned off by heart all the possible combinations of multiplication.
The possibilities are infinite.
Oh, well, I managed to do it anyway.
It's quite astounding. Nevertheless, you will allow me to point out that I am by no means satisfied, mademoiselle. If you do without calculations, you ought to have found the answer by dual process, or inductive and deductive mathematical reasoning, and that is why you should arrive at all your answers. Memory is a deadly enemy in mathematics, and though in certain advantages, arithmetically speaking, memory is a bad thing. So I'm not happy at you at all. You just won't do it all.
No, sir.
Oh, well, forget about it for the moment and get on to get on to a different exercise.
Oh, yes, sir.